All right. The first one is cosecant. Now, remember, cosecant is abbreviated this way. Yes, that's the parent function. But you tell me, what is cosecant? The flip of sine, right? Cosecant I could write as 1 over sine. So here's the important thing. And this is how I remember them. Every place that sine is 0, I'm going to have an asymptote because I can't divide by 0, right? Y'all, yesterday when y'all were doing the puzzles and stuff, you got to a couple questions like that where it was undefined when it was 0, right? So tell me this. Look at your unit circle. Where is sine 0? Give me the first place you see that sine is 0. Okay, but give it to me in radians. Where are you at? 0 or 2 pi, right? So at 0, sine is 0, right? So that means I'm going to have an asymptote for the cosecant graph. All right, stay with me. Everywhere sine is 0, I have an asymptote, okay? So look at your graph because it's undefined, because if at 0, right, at 0, sine is 0. So if I do 1 over 0, that's undefined. So it's also at 2 pi. You're exactly right. So if I go over to 2 pi, what's happening? Asymptote. Where else do you see sine is 0? Pi. Look at your unit circle. Sine is the y, right? Where is y 0? 0. 0. Pi. Every pi. Thank you, Thomas. Every pi. So every pi I have an asymptote for my cosecant graph, and that is y. Now do this. Remember, I'm flipping it over, right? Go to pi over 2 on your unit circle. Pi over 2 is right there. What is the sine value at pi over 2? 1. What is the reciprocal of 1? 1. If I flip 1 over, I get 1, right? So what I'm asking you is, what is cosecant of pi over 2? 1. What is the cosecant of pi over 2? Cosecant is the flip of sine, so go to pi over 2 and flip your sine value. What is it? 1 over 1. Because this point at the top, this point is 0, 1, yes? This is pi over 2. So sine of pi over 2 is 1. The cosecant of pi over 2, flip 1 over, it's also 1. The flip of 1 is 1. So this value is 1. So this looks kind of funky, and I just want you to be familiar enough with this that you know what these look like, okay? Instead of curving like this, this flips up and hugs these asymptotes this way. This is not a continuous graph. At that point 1, so pi over 2, 1, and then it hugs up like a parabola. Now go to 3 pi over 2, which is halfway between these two asymptotes. It's negative 1. The cosecant of 3 pi over 2 is negative 1. So it's here. So this is going to be like a parabola upside down. Now this pattern is going to continue for cosecant. So instead of it being this nice curve, it's made up of all these little up and down parabola looking things. That's what cosecant looks like. So it looks a little crazy. but I just wanted you to see what it looked like and why. Everybody okay? What's the period of this graph? And what does period mean? A full cycle. So what is the period here? How long does it take to make a complete cycle? It does 2 pi. Look, it's up and then down, and then it starts repeating again. So how long did it take it to do an up and a down? 2 pi. So the period is 2 pi. For cosecant and secant, but not for tangent. Just for the first two. Yeah. How about the amplitude? How did I tell you we find amplitude? Rewind back. Amplitude is height, but it's the highest minus the lowest, and then I cut it in half. But what do you notice about this? It goes on forever up and it goes on forever down. It has no amplitude. So there's none. There's no amplitude. Amplitude is highest minus lowest divided by 2. It doesn't have a highest because it goes up forever, and it doesn't have a lowest because it goes down forever. So I can say like min minus max minus min divided by 2. Yes. Yes. This is none. It would be cut to the infinity. Right. Right. Oh, okay. All right. Listen, I'm just really skimming over this because I want you to have seen it before, but we don't do a lot with them other than we do more evaluating with these, but I wanted you to see what the graph looked like in case that comes up, and the asymptotes here where I'm undefined. So let's look at secant really quickly. The domain of this is going to be all real numbers, but you leave out every pi. That's the k pi thing. You don't have to worry about that right now. Yeah. Right. All right, so let's talk about secant. Parent graph. SEC. Yes? Secant. It's the flip of what? Cosine. Secant is 1 over cosine. So everywhere cosine is 0, I'm going to have an asymptote. So look at your unit circle and tell me where is cosine 0? Pi over 2 and 3 pi over 2. So pi over 2 and 3 pi over 2. And then that's my pattern, right? Skip one asymptote. Skip one asymptote. Bless you. Bless you. This is going to do exactly like sine and cosine does. It's just going to look like it's been shifted over. That's all. But I really need a starting point. So at 0, what is the cosine of 0? What is at 0? What is cosine of 0? 1. So what is secant of 0? 1. So this is 0, right? So if I plug 0 in, what I'm asking is, what is f of 0? What is the secant of 0? So go to 0. The cosine of 0 is what? 1. Flip that over. 1. How about at pi? Negative 1. Negative 1. And now I've got enough to pick up this pattern. And so everything else is the same from the cosecant. It's just literally been shifted over. And that's it. It looks the same. Period is still 2 pi. It still doesn't have an amplitude. all that is exactly the same. Again, I'm not going into too much detail with this. Normally in pre-cal, we shift, stretch, shrink, all that good stuff with these graphs, but we get really bogged down with it, and I would rather get to some trig identities. So I just want you to be familiar with what this looks like. Yes. And then the last one is cotangent. That's the flip of tangent, right? So there's my parent. The difference in this one and the tangent is just where tangent was 0 before, now it's undefined. And where it was undefined before, now it's 0, right? I feel like I do not have y'all whatsoever. You might have to know like where the asymptotes are. 2 pi. You can use unit circle. So looking at your unit circle, tell me, because cotangent, I could say that's the flip of tangent. I could also say that it's cosine over sine. So tell me where you think your asymptotes are here. Where it's undefined, which is where? Not where tan is undefined, but where cotangent is undefined. So what happens at pi over 2, tangent's undefined. So it's going to have a point, but at 0, right, tangent, so I'm going to have an asymptote here at 0. Then again at pi, so it's happening at every whole pi. Now remember, whenever you were doing the tangent, when you were doing the tangent, your asymptotes were at every half pi. Now they're at every whole pi. At pi over 2, my tangent was undefined, but my cotangent here is flipped, right? 0. Now, instead of going up, it's the flip, right? Everything's flipped, so it's going to go down to the right and up to the left, which is a little different than the tangent graph. But what I want you to do is take out your calculator so that you can see, if you do 1 divided by tangent x and do a zoom trig on it, you will see this graph there. Okay, same with secant, same with cosecant. You don't have a cotangent, cosecant, and secant button, but you can do 1 divided by those, do a zoom trig on it, and you will see this. Yes, there'll be another one at 2 pi. Cosine of the sine of negative 3 pi over 4. Our cosine is just inverse cosine, so we're just going to work inside out. So inside here, what is the sine of negative 3 pi over 4? So where is negative 3 pi over 4 on your circle? 3 pi, all right, look at your circle. Everybody go to 3 pi over 4 on your circle, Luke. What? 3 pi over 4 is here, right? So it goes 1 and then 1, 2. So I'm going to go the other way. 1 and then 1, 2. So I'm down at 7 pi over 4, yes? What is the sine of 7 pi over 4? Wait, go back. All right. I'm looking backwards at it. Did I go? Oh, yeah. Sorry. 5 pi. Okay. You go, all right, negative 3 pi over 4. So 3 pi over 4 is 90 degrees plus 1, 2. So I'm going to go 90 degrees the other way plus 1, 2. I'm at 5 pi over 4. What is the sign of 5 pi over 4? Negative root 2 over 2. Now, you have to remember, what does inverse trig function tell us to do? That's the reciprocal. But what this says, what the inverses say is, where is cosine the negative square root of 2 over 2? Remember, we had some of these where we were solving the triangles and we had to solve the equation, and to get rid of, like if we had cosine theta equals, I don't know, 2/3, we would do inverse cosine on both sides to find it. Well, if I'm on the unit circle, this just means, where does this happen? So look on your unit circle and tell me, where is cosine negative root 2 over 2? 5 pi over 4. So that's the answer. So I wanted to make sure you knew how to